Hello, welcome. Um, we're going to do a few little stations. We normally do these as stations around the room. So what I'm going to do for you guys is show you what the little stations were so that you can wonder about them just like you would have. But you can just see me do them and pretend that you are doing them. Some of these you can do at your own house too. You have the supplies like a cup and water. Maybe you have a paper clip lying around. This would be the one for you. Ready? Okay, here it is. If you have a glass of water, you need to fill it all the way up to the top, and then gently, we are going to try to slide your paper clip onto the water. And you see what happens? Here's another one. We'll try another one. Gently slide the paper clip on top of the water. And look what happens to the paper clip. What? I thought paper clips were more dense than water. Okay, so the question for you is, why do the paper clips stay on top of the water instead of falling into the water? Okay, the paper clips were hanging out on top of the water, but now look what happens when I try to take the paper clip off. It goes down to the bottom. Okay, here's why that's happening. On top of the water are a bunch of water molecules, and the surface tension is when the molecules are sticking close together to each other, and that's what's holding the top surface, gives it a surface on it, like a water layer. So that's what's holding the paper clips and allowing them to float on top. When I stuck my finger in there, it broke the surface tension so that the paper clips now fell to the bottom of the glass. Okay, our next little experiment is taking a glass of water, filling it to the top with the very top with water, and now I'm just slowly placing pennies into the water. Okay, pennies into the water, and look what's happening on top of the water. On top of the glass. Okay. See what's happening to the water level? As I'm filling up, I'm displacing the volume of water with pennies. And what's happening to the water? Okay, what is causing that big bubble on the top of the water? And why can I just make it get bigger and bigger and bigger? And I've run out of pennies. But it's starting to come out, it looks. Okay, what's making that? Okay, the water on top of the glass forms a half of a sphere. Sometimes we call it a bubble. But it does that because the surface tension of the molecules are holding it tight together. The easiest shape to make is a sphere. So it's trying to make a sphere, a part of a sphere anyway, on top of the water. A sphere has the smallest surface area possible for a shape. So that's why it's trying to make that shape on top of this water. Okay, here's another one for you. I have the glass of water again, and I just sprinkled pepper on the top. Why does the pepper stay on the top of the water? Surface tension. Okay, so the pepper is just floating there. Now, I'm going to take some dish soap, and I'm just going to drop a drop of dish soap onto the surface. And watch what happens. Okay, why does dish soap make the pepper go to the edge? So the dish soap in the water wants to break the surface tension. Okay, it tries to split the particles or the molecules away from each other, but the pepper still wants to float. It still wants to be on top of the surface tension. So as soon as it breaks the surface tension in the center, it moves to the pepper goes to the edge where it continually wants to float on the surface, where there is some surface tension still. So that's why the pepper moves to the edge as the dish soap breaks the surface tension in the center as it goes out. Okay, here's our next one. We're going to see, I just have a pan of water, and I have made a boat. Okay, a little boat is out of an index card. It's just a triangle. And we're going to see what happens when I stick the boat into the water. It just floats. Okay, the boat floats. The surface tension of the water keeps it up, up, up. Okay, what I'm going to do now is put a little motor on the boat. Okay, I'm going to get a little dish soap on my finger, and I'm going to put a little soap on this little motor. I'm going to put the soap right here in front of the triangle. Okay, so now I'm going to turn it with the little soap boat facing down into our water, and it cruises around. What? Why does it cruise through the pan? Okay, in that spot where the soap is, it breaks the surface tension. So when it breaks the surface tension in the bottom of the boat can ride like this. So when it pushes its weight down, it speeds it up and shoves it across. It pushes down, speeds it across, and that's why your little boat, it breaks the surface tension in that spot, but not in that spot. So that spot's trying to float. So as it moves across the water, breaking the surface tension, keeping the surface tension, breaking the surface tension, keeping the surface tension. Okay, till your soap motor runs out. Okay, so what is the overarching theme that allowed our water to have such unique properties? Surface tension! Okay, surface tension, either keeping the surface tension, allowed the things to float on top, or breaking the surface tension, like the dish soap did. Just like when you're washing your dishes. What cuts through the grease? Dish soap! It breaks the surface tension. Okay, so this is actually what the surface tension looks like at the surface of the water. There's an H2O, H2O, H2O. So all of these together are what creates the surface tension, and that's where your stuff can float. If you put the dish soap on top, and here's what's going to happen. Or you put your finger in and the paper clip dives down because you broke the surface tension right there. So you allowed it to give it a space, which is where the weakness is, so that whatever it is can break through the surface tension so that it falls down into the water. Okay, anywhere you break the surface tension, that's where it's going to be weaker, so that whatever it is can go all the way down or however far into your water. Okay, think about what uses surface tension in order to survive and get food and eat. Water bugs walk all over the surface so they can get from one place to another with their little teeny legs. Okay, water striders walk all over the water is one example.